Zach, thank you so much for joining me on the Hangout here today. I'm excited for the new boards that you guys are launching at Particle. Tell me about the announcement.
For sure. So a little bit of history to start. We've been doing this since 2013. Our first dev kit that we launched was the Spark Core on Kickstarter back in 2013, back when we were named Spark. That was a Arduino compatible Wi-Fi development kit for building Wi-Fi connected products. We then launched two what we call our second generation products, the Photon and the Electron, over the last few years. The Photon is also Wi-Fi and the Electron is cellular. So right now, up until today, if you were working with Particle, you could build Wi-Fi and cellular connected products on our platform. And today we launched our third generation hardware development kits, which all are use a technology we're calling Particle Mesh, which is our mesh networking solution built on top of Thread. And so it's three products because we like symmetry. So Gen 1, one product, Gen 2, two, and Gen 3, three. The Argon, the Boron, and the Xenon. Argon is Wi-Fi plus mesh plus BLE. Boron is LTE plus mesh plus BLE, and then the Xenon is mesh and BLE. So what that means is you've got, again, Wi-Fi and cellular connectivity, but now every Wi-Fi and cellular device can create a local mesh network that you can use to extend and sort of cover a space with sensors, and Xenons can join and extend that network. So you can build out these really robust networks in a bunch of different places, whether you're at home or whether you're doing something in an industrial facility or an office or a hospital. You can build out these sensor networks using Particle Mesh.
All right. Now, mesh has been like a buzz I've heard for a while now. I've heard about mesh. It's not a new technology necessarily, but it's I haven't seen it on a project board yet. Tell me a little about why mesh is happening now in the project board space.
So there's generally been this gap in the radios we have available to us, which is, we can go back in history, right? We've had cellular networks for a while. So in theory, it's been possible to build cellular widgets for a long time. And if you think about how long waiters have been carrying around those cellular like point of sale things, right? We've been doing that for a while. It only became really feasible for makers and hobbyists over the last couple of years as it started to get more affordable, because it used to be that those things were really expensive. But fundamentally, the tech has been there. Wi-Fi, we've had Wi-Fi networks for a long time, but before the Spark Core, everything to build a Wi-Fi product was really expensive. So really, with the Core and with the Photon and Electron, we took technologies that had been around for a while, but had finally gotten to the point where they were cheap enough, they were low power enough that you could feasibly do them for IoT, use them for IoT products. And so if you look at the spectrum of radios, you've got radios with tiny ranges and radios with giant ranges, right? So on the wide ends of the spectrum, Bluetooth Low Energy is personal area networks designed for me as a human to have Bluetooth stuff around me, wearables and things like that. And then on the opposite end, you've got satellite connections, right? Global infrastructure of connectivity that's unbelievably expensive, but is there if you really want it. And then, so you've got like these things we've got taken care of, Bluetooth, satellite, and then we come in and we've got Wi-Fi and cellular. Wi-Fi is bigger than Bluetooth, cellular is smaller than satellite, but we're sort of coming towards the middle, right? And then there's been this sort of gap in between, which is what happens when I want to deploy a network and it's bigger than a home and it's it's bigger than a home and smaller than a city. There's this gap, and this gap exists in places like hospitals and mines and farms and campuses, right? Any building or set of buildings that's bigger than a 3-bedroom house, right, is bigger than Wi-Fi can handle, but often not a good fit for cellular. And that gap, there have been a lot of different technologies sort of poking at it, right? So there's mesh networking, which there have been versions of for a long time, Zigbee, Z-Wave, mostly focused on like smart home, security systems, connected light bulbs, things like that. There's also been a big push into LPWAN, so things like LoRa that are super long range low power sub-gigahertz radios as a different way to tackle a similar problem. And so we've been looking at this area for a long time and trying to figure out like, okay, what's the right technology to use here? And so when we build new stuff, we tend to do it, we come from a place of saying, what problems are our customers trying to solve that they're stuck on? And as we saw a bunch of folks who were shipping products and wanted to add local radios to them, because they'd ship a product that worked, but they wanted to add other sensors to it. And so they were all setting up their own kind of local networks. And as we went through them, we said, you know, they would really benefit from a mesh network. Mesh networks would be a great solution for this. But the existing tools are poor. The technology exists, but everyone has to sort of rebuild the networking stack on their own. It's very similar to the way that Wi-Fi and cellular were before we tackled them, right? Is to say they were there, but they were difficult and expensive and challenging to kind of work through. So that's when we said, okay, we want to go after this and try and build something that just works out of the box. And so that's where particle mesh comes from.
That's great. And now the technology that the mesh part of it is built on, and you were talking about open thread or the thread technology, the protocol.
Yeah.
How is that helping this take shape, and what should people know about it?
So, a little bit of history there too. For a while, the popular mesh thing was Zigbee. So if you wanted to build a mesh networking thing, if you used XBs, you know, like Zigbee was sort of the underlying technology. Zigbee is a very opinionated solution. It is a full stack protocol, goes all the way up into the application layer. And so if you want to, it's really good if you want to build a connected light bulb, right? Philips Hue is a Zigbee product, and built into the Zigbee spec is how connected light bulbs should work. That's great, but what if what you're building doesn't fit with the spec, right? Zigbee is very opinionated, and so the history of Thread is that when Nest went to start building mesh network products, they looked at Zigbee and said, this isn't exactly what we want, and it's very opinionated in ways that don't match our opinions, so we want to build something else. And they built internally this technology that they later made available to the public called Thread. Now what's interesting about Thread is it's not as complete as Zigbee is. It specifically excludes the application layer at the top. What that basically means is that like it gives you all the protocol stuff, but then how things talk to one another is up to you. So it's kind of like, you know, Wi-Fi. Wi-Fi builds this network, but then how computers send each other's messages, you know, the TCP stack, HTTP, like the way that our web browsers talk, that's a layer on top that isn't part of Wi-Fi. So Thread basically does the same thing. It sort of builds it from the bottom, but it leaves this area at the top, which says when you go build something with Thread, you have to figure out what your application layer is. And at Nest, they have an application layer they call Weave, which is specifically designed for smart home products, the kinds of products that Nest builds. If you're not building a smart home product, it's not necessarily the right kind of solution, and it's also, you know, internal to Nest. So that's where now Nest has released Thread. It's a great technology, but it's missing this layer on top. So that's where we come in and say, okay, we really like everything they've built. It's small, it's reliable, it's secure, all these positive things. But then there's this piece on top that is missing, and we can build that piece. We can make the application layer that our customers need so that when they go build a mesh network product, it just works out of the box the way that they expect it to, and they can build a great prototype using these dev kits like completely, you know, by just clicking a couple buttons, and then when they want to scale it up, they can use the same technology to power a product at massive scale, right? That's what particle mesh is, what we're building on top.
Great, that's great. And now I'm thinking about also the hardware. This is kind of a departure for the form factor too, right? The new boards are going after like the Adafruit, the Feather form factor, and I have the the Photon here.
Yeah,
a little bit smaller and a little bit of a different form, right? And so, what was the decision to go over to the Feather form?
So when we made back in 2013, when we made the Spark Core, there wasn't really a standard form factor for these tiny breadboardable dev kits. At the time, there was the Arduino Pro Micro, and the Teensy were around, but they each had different form factors from one another, and they were also too small for the Wi-Fi modules that we used at the time. Were too big to fit that thing. So we were like, okay, I guess we got to do our own thing. So we made our own form factor for the core, which we then used again with the photon and the electron. Now, what we really wanted to exist was some kind of ecosystem around a standard form factor. And you see this happening with Arduino and with Raspberry Pi, where if you're making an Arduino-y kind of thing, right, every dev kit of that form factor has basically said, okay, we're going to have these 2 rows of pins, the same stuff exposed. And that's really nice because it builds this really strong accessories ecosystem. And Raspberry Pi is the same way, right? That sort of Pi hat form factor has become standard amongst other products that aren't Raspberry Pis. So we were hoping that somebody would start to drive out, like build out an ecosystem. And when Adafruit launched Feather, I think they did a spectacular job of designing it, of making it work very well with lots of different hardware. Limor, Lady Ada, was really thoughtful about the pinout design. Like she just really got it right. And so we'd been waiting for that, for somebody to do it. And we saw what they'd done and said, this is exactly what we're looking for. We can fit our stuff on this form factor. It has all the features that we need it to. It gives us this ecosystem of accessories that, we build a couple accessories, but only like 3 or 4. Adafruit already has 50 of these things, and there's more coming out all the time. So that's when we said, okay, they're doing great work here. We'd like to be part of that ecosystem. We'd like to contribute to that ecosystem. And we'd like to make this a standard. We want everyone who builds little breadboardable dev kits to make them Feather compatible, to use this form factor so that we all benefit from all of our products working together well.
Great. And I think it's a really smart move. I've been a fan of the Feather form for a while now, and the way that they integrated the little battery like jack to be able to get the like LiPo cells or coin cells in there. I think it makes sense for IoT stuff like you're doing.
Well, that's where, Adafruit's good at this stuff because they've done it for a long time. So, Limor, when she goes to design something, she thinks she's built all this stuff already. She knows what people like. She knows what people don't like. She has her own opinions about what she likes and doesn't like, and it gets into the product and it ends up great. So,
yeah. All right. So now I know you guys have a lot of customers, corporate customers or entrepreneurial customers who are trying to build out products and want to scale it up. But for a lot of people who come to my channel, they're mostly tinkers who are making their own projects. What's the appeal for them for going with the new suite of the mesh boards and using those for their small scale IoT projects?
So the big thing is this stuff just works. When you're building a weekend project, and this is where, it's oddly similar, I think, between what the interests are of a maker building something on a weekend and a company building something they want to scale. Like, you want to spend your time on the things that make your thing special, right? And so the reason that Arduino was so successful when they launched however many years ago was because at the time, embedded systems development meant you had to be an expert in embedded systems development. You had to know this stuff. You had to have a degree, basically, to do any of these kinds of things. And Arduino said, you know what, we're going to make it so that students and artists and designers who have no business being in embedded software development can go build great things with a much easier and simpler set of tools. And that kicked off this entire ecosystem as we know it, right? So, we see our role is to take that one step further and say, this stuff should be accessible to everybody. It should be really easy to use, and it should the technology should get out of your way so that you can do the thing that you're trying to do, right? Which, if you're spending a Sunday afternoon building a robot, you should spend all of your time making the robot do cool stuff and 0 time opening TCP sockets to get your controls working, right? Like, that stuff underneath should just be taken care of. And this is something that the software world has gotten right. If you think about programming languages and how much simpler they've gotten over the last 10 years, right? The ecosystems around things like JavaScript and Python and Ruby and Go that have just become really powerful but also really easy to use tools. We want to bring that same combination to makers, to hobbyists, to IoT, so that this stuff just works. The technology gets out of your way, and you can build the thing you want to build.
Right. Now, but from a practical perspective, though, like what kind of projects do you think are going to be opened up by having access to these mesh nodes and being able to expand out beyond Wi-Fi range? Is there anything you guys are already thinking of that people might be able to dig their teeth into to get a project going?
So, it's broad. I'd say the most common thing, the most common use for mesh is sensor networks, right? So if you think of like, I've got a house and I have a thermostat, and the thermostat knows what temperature it is where the thermostat is, right? Which is on the wall in your hallway, wherever you had the thermostat installed. Right. It doesn't know what the temperature is in every other room in the house, right? So you want to add a temperature sensor in every room in your house? Great. Super easy to do with mesh. Or let's say you have a garden and you want to be able to monitor the moisture of the soil to know when it should be watered. But again, different parts of the garden, there's part that's kind of under the roof, that's part that's not. So they're going to get different moisture levels. So you can stick sensors all around the garden and check the whole thing. And so those kinds of things, you want to track a shelving system to see like which shelves are stocked and which ones aren't, to see what's in your pantry, to see what's in your fridge, to see what's in a warehouse, to see what's in your garage, right? Like any of these, they're all versions of sensor networks. And that's where I think mesh is best. Now it can do controls too. It's not limited to sensors, but when you get into the super low power stuff, that's what we often see people going to build.
All right, and then one other part of the announcement today was that you had improved the cellular data plan, right? For the for the LTE boards, there's a jump in the pricing or the data that comes through, right?
Yeah. So previously we included 1 megabyte of data for $2.99 a month, and now it's 3 megabytes of data. And of course, we're talking megabytes, so no one's streaming Netflix on these plans. But 1 megabyte's interesting in that it's enough to run a sensor-based product, but you still have to be a little bit thoughtful about what messages you send, which ones you don't, right? You have to think like, well, I don't need to always send the temperature. Why don't I just send the temperature when it's above 80 and below 60 or something like that? Right. And I think that's the difference between 1 and 3 megabytes is it's still, we're not changing what it's for. It's still for sensors and controls. It's still for IoT stuff. But now you can be a little bit less careful about how you optimize your data consumption, right? You can just sort of let it run, and it'll you're less likely to hit your cap.
Yeah, it's cool, and I think it's cool that you guys have that option for people who want something that's maybe more remote than what Wi-Fi can reach to,
Yeah, I mean, a lot of places, and this is cool also because we're adding LTE with this. We were previously on 2G and 3G, and LTE is everywhere now. Once upon a time, it was like 2G was where all the coverage was, and then 3G was like in the cities, and it's like the populated areas had the new stuff, and the less populated areas were one generation behind. And now with LTE, it's like everybody's got the same thing. LTE's got the broadest penetration, so LTE means better coverage than anyone was getting with 2G and 3G, which is great.
All right, Zach, I'm going to let you go here soon. Just give me the last pitch. What's the pricing we're looking at for anyone who actually wants to get these boards, and when are they going to be available?
Pre-order is available today, particle.io/mesh. We're going to be shipping in July, and between now and July, we've got special pricing for all three of the products. The Argon, which is Wi-Fi, is $15. The Boron, which is cellular LTE, is $29, and the Xenon is $9. So all three, all three are really priced to move. No, I mean, we want to make this stuff accessible. Everybody should be able to afford this stuff. So that's really what we've shot for in the pricing. And if you Within the first 24 hours, it's free shipping for the first day. So get on there.
Cool. And now that $9 Xenon board, even though that price sounds really attractive to me, like that's one of those boards that's not going to work that well without one of the other boards to kind of piggyback it up to the cloud, right?
Right. So I mean, they can do peer-to-peer communications, but generally speaking, it's all designed for there to be some backhaul through Wi-Fi or cellular, or there's also actually an Ethernet accessory. So basically, any node can be Ethernet hooked in to be a wired backhaul to create a local network. And then the Xenons become the way that you can just scatter these things everywhere.
All right, Zach, thank you so much for joining me here. And I wish you the best of luck on this launch. And I think the boards are really cool. And I'll let you go, but thanks for calling in.
For sure. Thanks for having me. Take care.